2,800 cubic kilometers of rock and ash hurled 30 kilometers into the sky. 75,000 years ago, this single eruption choked the planet in sulfur and crashed global temperatures by 15 degrees. Our species may have collapsed to as few as 3,000 survivors. The eruption that nearly erased all of humanity didn't finish the job, and the reason why is still written in your DNA. Far beneath the tangled jungles and mist-shrouded ridges of northern Sumatra, two tectonic giants collide. The Indo-Australian plate grinds beneath the Eurasian plate at a relentless pace, 6 centimeters each year, feeding a chain of volcanoes that stretches across the Sunda Arc. Over hundreds of thousands of years, this slow-motion crash forced seawater and minerals deep into the mantle, melting rock at depths of 80 to 120 kilometers. The resulting magma, rich in water and gas, rose through the crust, pooling in vast underground chambers. Beneath what is now Lake Toba, a single reservoir silently accumulated for more than 150,000 years. Seismic studies reveal a complex, multi-level system, a hidden engine slowly building toward catastrophe. While this chamber simmered, the world above was already in flux. By 120,000 years ago, early Homo sapiens had begun their cautious spread out of Africa. Fossil evidence places our species in the Levant, Arabia, and along the southern Asian coastlines, small, scattered bands navigating a world dominated by megafauna and rival hominins. These pioneering groups faced shifting climates, unfamiliar predators, and the constant threat of hunger. Genetic studies suggest their numbers were thin, never more than a fragile web of family groups stretched across continents. Yet even as humans searched for new territory, the ground beneath Sumatra was changing. Zircon crystals, locked inside the magma, recorded a story of slow, relentless growth, each layer a timestamp of pressure building in silence. For over 150,000 years, the chamber expanded, fed by repeated injections from the deep mantle. The crust above began to bulge, rising imperceptibly as magma and volatile gases pressed upward. The world's largest ticking time bomb was nearly ready. On the surface, no one could sense the scale of what was coming. Early humans, already scattered and vulnerable, lived within reach of a force that could reshape the fate of their entire species. The stage was set. A restless earth, a simmering chamber, and a species on the edge, unaware that everything was about to change. Pressure beneath the surface reached its breaking point. In a matter of hours, the crust above Lake Toba ruptured, unleashing more than 2,800 cubic kilometers of magma and pulverized rock, an eruption so immense it dwarfs anything in recorded history. The blast drove a column of ash and gas 30 kilometers into the stratosphere, high enough to pierce the uppermost layers of the atmosphere. Dr. Peter V. Gerlach, whose team modeled the plume's rise, described it as a planetary scale event. Our simulations show the Toba plume lofted to 30 kilometers, keeping fine ash aloft for up to 2 years, enough to blanket much of South Asia in a thin, climate-active veil. Within 200 kilometers of the caldera, the land vanished under more than 6 meters of hot ash, enough to bury forests, rivers, and every living thing in its path. Further out, a belt of ash over 10 centimeters thick stretched for thousands of kilometers, crossing the Indian Ocean, the Bay of Bengal, and deep into the Asian mainland. Tephra from this eruption settled as far as the Arabian Sea, forming a layer that geologists still use as a time marker in sediment cores today. The numbers stagger the imagination. 2,800 cubic kilometers of ejecta, 10,000 times the volume of Mount St. Helens in 1980. The eruption's violence was matched only by its reach. Fine ash circled the globe, filtering sunlight and setting the stage for a volcanic winter. For early humans, already spread thin across continents, the world was about to darken in ways no one could have imagined. Genetic clues buried in our DNA reveal just how close Homo sapiens came to vanishing. Genome scans and mitochondrial DNA studies point to a dramatic contraction in our numbers between 75,000 and 70,000 years ago. Stanley Ambrose described it as a near collapse. The effective population size of modern humans plummeted to somewhere between 3,000 and 10,000 individuals. That's fewer than the population of a small town today. The evidence is written in the loss of genetic diversity. About 20% of our ancestral heterozygosity disappeared in this interval, a signature that still marks every living person. David Reich and Mark Lipson, analyzing whole genome data, note that this genetic bottleneck aligns with the timing of the Toba eruption, but warn that such a sharp reduction isn't always the result of a single disaster. Yet the coincidence is striking. The world was colder, drier, and more hostile than any generation before had faced. For thousands of years, humanity was squeezed into isolated pockets, each group carrying only a fraction of the genetic legacy that once spanned continents. The fate of our species hung by a thread. Survival was not guaranteed. Along the battered coastlines of the Indian Ocean, life clung to the margins. Archaeological teams led by Dr. Michael Petraglia have uncovered shell middens in southern India and Sri Lanka, some dating back nearly 78,000 years. These ancient refuse heaps, layers of discarded shells and charcoal, reveal a simple truth. Even as forests died and grasslands withered, the sea remained a lifeline. Early humans gathered shellfish, fished tidal pools, and relied on the steady rhythm of the tides when the land offered little else. Oxygen isotope records from marine cores, Delta 18O curves, trace a slow but steady warming after the coldest years. By 70,000 years ago, global temperatures had rebounded by as much as 6 degrees Celsius. As the climate eased, coastal vegetation returned, and fresh water became more reliable. Petraglia's excavations show that stone tools and shell beads continued to appear above and below the ash, evidence of resilience and cultural continuity. These coastal refugees, buffered by the ocean's stability, became strongholds for human survival, seeding the expansion that would follow. The ingenuity and adaptability forged here under relentless pressure set the stage for the resurgence of our species. By 68,000 years ago, the numbers began to climb. Genetic studies trace a sharp expansion, an echo of recovery after the bottleneck that nearly ended our story. This surge is written in the DNA of every living person, a signature that points back to a handful of survivors whose descendants fanned out across continents. Archaeological sites from South Asia to Australia record a sudden wave of migration, stone tools and ornaments appearing in places untouched for tens of thousands of years. The timing isn't random. As the climate warmed and coastlines stabilized, the pressure that had squeezed humanity to the edge now fueled a burst of exploration and innovation. The caldera itself remains as proof. Today, Lake Toba stretches 100 kilometers long and 30 wide, a scar left by the eruption, visible from space. Its steep walls and volcanic islands are reminders of the force that once threatened to erase our lineage. Ash from that blast still marks sediments across the Indian Ocean, a geological timestamp linking distant landscapes and distant peoples. The eruption's legacy endures, not only in the rocks beneath our feet, but in the genetic threads that tie us all to a single, fragile beginning. Humanity's greatest trial became the crucible for its expansion, a catastrophe that, rather than ending us, set the stage for everything that followed. 75,000 years ago, 2,800 cubic kilometers of magma nearly erased our species. Instead, Homo sapiens emerged from a genetic bottleneck, fewer than 3,000 souls, reshaped by survival. The pressure of that volcanic winter forged the minds that would eventually span continents. Catastrophe didn't end us, it defined us.